Welcome to the class. Dear students, today we are going to discuss about halogenation of benzene. Halogenation of benzene is an example of the characteristic reaction of benzene, which is electrophilic aromatic substitution reaction. To understand electrophilic aromatic substitution reaction, we need to look at the structure of benzene. So this is the structure of benzene, and as you know, the benzene is made up of 3 double bonds, or you can say 6 pi electrons, and these 6 pi electrons, they are in constant dynamic motion. That is, the 3 double bonds switch their place to the alternate positions. They are in constant dynamic motion. They are delocalized. Okay, there is a delocalization of electron, and because of this, the overall structure is a combination of these two structures of benzene. Okay, so that is the resonance hybrid structure of benzene. Why we call it as resonance? Because the delocalization of electron is referred to as resonance. So this is a resonance hybrid structure of the benzene, that is the combination of the two canonical forms of benzene. Now if we put an electrophile into this system, the electrophile is deficient of electrons, and benzene ring is rich in electron. It has got 6 pi electron. So electrophile will get a natural tendency to take an electron pair or to snatch an electron pair from the benzene ring, but it is not able to do so. Why it is not able to do so? Because the 6 pi electrons are in constant dynamic motion. So it would feel as an immature player which is going to take a football from mature players, from a team of mature players. That situation here arises. So it will never get its electron pair. So this actually makes benzene very unreactive, or in other words, it makes the benzene ring very stable. And such stabilization, because of resonance or because of delocalization of electron, is referred to as the resonance stabilization. And the character of benzene is it would never partake of its resonance stabilization. It would never do anything that would harm its resonance stabilization. Therefore, the electrophile will never get an electron pair from the benzene ring. Then the question comes, what option does E plus has? There is another option. The benzene ring is ready to partake with its H, and the H would go to a base and substitute it for E. That is the option that is left, and it does like this. So what kind of reaction benzene undergoes? Electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reaction. So today we are going to see what is halogenation. To know what is halogenation, first we will see its reaction and then we will go for its mechanism. Let's see the reaction. Let's see the reaction of benzene, halogenation of benzene. So the benzene ring here, I'm going to draw like this. When it is reacted with bromine, for example, in the presence of a Lewis acid catalyst, here we take FeBr3, then what would result? Br, bromine substitutor bromobenzene, and HBr. This is the overall reaction of the bromination. Now let us look at its mechanism. So, like in the earlier video, we studied electrophilic aromatic substitution reaction has 3 steps. Step number 1 is formation of electrophile. So, here step 1, formation of electrophile. Let us see how the electrophile is formed here. I am writing Br2 as Br negative, delta negative. Now I react it with a Lewis acid catalyst. Now being a Lewis acid catalyst, FeBr3, this FeBr3 has an empty d orbital which can accept a lone pair of electron. So this Br, it goes here, and the result is Br positive and FeBr4 negative. Please note that here it is a Lewis acid, while here it's the conjugate base of this acid. So this is the first step, formation of electrophile. Now the electrophile is born. Now what it should do? Yes, you guessed it right. It should attack the benzene ring and form a carbocation. So the step 2 is formation of a carbocation. Formation of carbocation. Let us see how it does that. So we have Br plus here and it attacks the benzene ring. I'm going to draw the bond here and I'll show it here. Suppose it attacks at this position, it takes this electron pair. So we get something here, one H is there, okay. So it has taken this electron pair and H is already there. Now when it took this electron pair, this carbon didn't have any loss. The loss that was bad was by this carbon atom. This electron was given to your Br. So the positive sign will come here. Now to compensate this positive sign, this electron pair would go here and we get a new structure. Let me draw like this. This would go here. So now the electron pair, when it shifted here, this carbon didn't have any loss. The loss was bad by this carbon. So the positive side come here. Now to compensate this, this would go here and we get a new structure. Now when this came here, this carbon didn't have any loss. This carbon bared the loss. So the positive sign now comes here. Right? So these are the three structures that are formed. So overall we can write these three structures as a hybrid structure of the carbocation. Br is here, H is here, and the positive sign is always rotating inside the benzene ring. This, my dear students, is a very unstable condition because benzene naturally is electron rich species and this condition would not last for long. So the third step is abstraction of proton, and in this and that step you will see that the benzene ring is restored, that is the 6 pi electrons in the benzene ring is restored. Let us go to step number 3. Okay. Step 3, abstraction of proton. In this step, the carbocation, which is not so stable, very unstable in fact, the H, in the step 1 we found that there was a conjugate base. Do you remember the conjugate base? Yes, it was FeBr4 minus, right? This would take, our benzene carbocation is very unstable. This electron pair would go back into the benzene ring and H plus goes here. So we get bromobenzene and HBr plus our Lewis acid catalyst FeBr3. The catalyst doesn't participate in the reaction, it recycles itself. So here are the 3 steps of the halogenation of benzene, which is an example of electrophilic aromatic substitution reactions. There are other examples of electrophilic aromatic substitution reaction along with bromination. They are nitration, sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation. Dear students, if you like the video, please subscribe for it. Thank you.